Today we're going to be going over the differences between nuclear fission and nuclear fusion. The two are opposites, with fission being that it's tearing apart. So you'll see it goes from one big unstable nuclei, such as something like uranium, which can give you atomic bombs, radioactive waste, and nuclear power, and it is splitting and making two smaller atoms or nuclei and releasing neutrons to make them more stable. Whereas you have fusion, on the other hand, that is smashing together two very small atoms, such as the two hydrogen isotopes, and releasing energy. So it's smashing them together and releasing energy as a byproduct of making the new atom of helium. This type of energy from fusion is common in nature. It is the sun itself. It's a self-staining fusion reactor. It's mostly clean. However, what we use more regularly in nuclear power plants is nuclear fission. Fission is the sun. Nuclear power plants is fission. For nuclear fusion, let's do a little practice. So fusion again is typically two smaller nuclei fusing or going together to make a larger nuclei or atom and releasing energy. Here are a few examples to talk about nuclear fusion. An example, the main example we typically see is, so you'll have the hydrogen isotope with the mass of 2 plus another hydrogen isotope. They are fusing together. They're going together to make helium and a neutron and release energy. So they're fusing. You'll see 2 hydrogen fuse together to make 1 helium. In another equation, on the right side, you'll see lithium plus hydrogen is fusing or going together to make helium. You're adding the top 2 numbers and bottom 2 to make sure you have the equal amount on both sides still. So you'll have 6 and 2 for the atomic mass, which makes 8. So if you go over to this side, the 2 times 4, remember the invisible parentheses, is 8. So they both have an atomic mass of 8. 3 plus 1 is 4. So there's 4 for the atomic number. So for this side, you'll do 2 times 2, which would give you 4 for the atomic number. Remember, it is 2 smaller fusing together to make a larger. Nuclear fission, again, is the opposite, where it's taking a large unstable nuclei, shooting the electron into it, and releasing 2 smaller, more stable nuclei and more neutrons and energy. So, which nuclear equation is a sample or example of nuclear fission? So you're going to have to think, let's see, if we have uranium and a neutron on one side, and you have 1, 2 on the other side. So if you go from 1 atom to 2, is it fusing together, or is it fission where it's splitting apart? So you go from uranium into 2 more stable nuclei. So here, this is fission because it's going from 1 to 2. Our next one, we have one atom to another and helium. So you have to think, what is taking place here? Is it going from 1 to 2 for fission, splitting apart, or is it going from 2 to 1 and fusing together? So here you have from 1 to 2, which is fission, and then you want to notice the 4-2He as an alpha particle. So it's releasing an alpha particle to make a more stable nucleus. Our next one we have is oxygen going from 1 to nitrogen and releasing a positive beta particle. That's the plus one, but it is a beta particle. Remember, you want to have the numbers on the bottom equal on both sides and the numbers on the top equal as well. So if there's 15 on one side for the atomic mass, the other side needs to be 15. So 15 plus 0 for the electron is 15. 8 for oxygen, so 7 plus 1 would be 8 also. Next you have aluminum. So you have aluminum plus the helium, or He, and it is going from 2 to oxygen. So if you have 2 going to 1, think back, is it fusion or fission? 2 to 1. These two are going together to make a more stable nuclei of oxygen. So they are fusing, it is fusion. The final one, we go from one atom to one atom and a release of an electron. And you'll see at the bottom, it's 93 on one side, which needs to be 93 on the other. That means you take the 94 and subtract the 1 to make 93. And the top has a mass of 239. So the other side should have 239. 239 plus 0 is 239. On this one, is it alpha, beta, or gamma? So with the symbol here with the electron is beta. Beta is turning a neutron into a proton and releasing an electron from the nucleus. Whereas alpha is taking 4, it's decreasing in 4 for the mass number and decreasing in 2 for the atomic number for alpha. Gamma does not have a change to the nucleus, however, it does release energy.